Hello everyone and welcome to our webinar today where we'll be discussing how to use the cloud to realise the potential of your plant and your people. My name's Claire and I'll be your host. Before we get started, I'll just cover off a few housekeeping items. As we're recording the webinar today, we have muted all the lines, but if you'd like to ask a question at any time, please do so using the question pane on the right-hand side of your screen. We do have some poll questions today, so please take part in them. And lastly, everyone will receive a copy of the slides. Today's presenter is Tim Shire. Tim started his career as an engineer in utilities design for an EPC company before joining KBC in 2006, where he worked initially as an energy efficiency consultant. He's worked on a range of projects in oil refining, petrochemicals, gas and LNG worldwide. From 2014, Tim led KBC's Consulting Innovation Programme and was product manager for KBC's suite of energy software. He currently works on new solution strategy and launch and is the product manager for KBC's Copilot programme. I'll now hand over to Tim. Hi Tim, over to you.
Thanks, Claire. Okay, I'm just going to take over control of the presentation. Okay, so I'm just going to start by, I guess most of you don't need reminding that there's a kind of new digital era approaching in our industry, and there's a huge amount of promise from all these digital technologies. So there's this potential to get sort of bigger and better insights, so algorithms and analytics that can spot things that human beings can't, big data joining up all this isolated data to be able to find broader solutions and more accurate simulations and tools to kind of take the guesswork out of decisions. And the hope is that this is going to be faster and more efficient. The machines can do this in an automated way, hopefully, and we're kind of slowed down and constrained by human capabilities and skills. So there's a lot of people retiring. It's just a challenge to train up a new generation, and there are a lack of digital natives. So we all believe that digital technology has a huge amount of opportunity, but actually at the moment people are maybe struggling to really get that into practice. Now at this point we're just going to do a quick poll. I'll hand back to Claire. So just to gauge, I guess, some of your opinions on where the challenges lie and what it's going to take to make digital work.
Thanks, Tim. Yeah, so our first poll question, which is on the screen now, is which skill do you think will be most important for achieving digital excellence? So all you need to do is just click on one of the options on the screen. So you've got traditional engineering, data science, information technology, change management, or other. Okay, so I'll just wait for a few more of you to select your responses. So which skill do you think will be most important for achieving digital excellence? Okay, so let's see the results. Okay, so 38% of you said change management, followed by 31% information technology, then data science at 17%, and traditional engineering at 7%. Okay, so I'll just hand back to Tim.
Okay, thanks very much, Claire. And we've conducted this poll with other groups and seen quite a similar pattern, that actually where people see the biggest challenge is around that change management. So there's technology there, and you do need IT, and you do need data scientists who understand the technology itself. But the real issue is, well, how are we going to use this technology, and what are we going to use it for? And if we've got this technology, how are we going to actually build it into the way we work, build it into the things we do, and make sure that people are able to really take advantage of it? And so, yeah, that pattern is quite common. And I think, we all need to be aware that this is not so much a technology problem. It's really a human problem as much as a technology problem. Now, when we start talking about digital technology, I thought it would be worth just talking about, well, what have KBC got to say about digital technology? And so there's a slide with a load of facts about KBC. Now, a couple of that stuff I expect you're already familiar with. So KBC have a very strong historical track record as a consulting company, and we've got a wide range of consulting engagements up on there. And KBC has a very strong track record as a process simulation or and general simulation technology company, and we're very strong in certain areas there. What you may be not so aware of with KBC is that we, about a year or two ago, were acquired by Yokogawa, and as part of that acquisition, a company called Industrial Evolution has become part of KBC. Now, Industrial Evolution were actually the pioneers of DaaS, data as a service, and IIoT in the energy and chemicals industry, and they started over 20 years ago, before Industry 4 and cloud and all these things were words that people were really using. We were doing this cloud-based data sharing, and as you can see from the stats on there, we're behind the firewall of a lot of major blue chip, very conservative oil and gas and chemical companies. We've got our own private cloud. We've got an IT consulting and implementation services team. So KBC now has these three parts, so consulting, software, and IIoT. And we're not just a services company who's now trying to do some cloud stuff. You know, we're very fundamentally a cloud company, and we're using this, this rich heritage of cloud expertise to deliver software and services to people. So the purpose of this webinar was to talk about how we can use the cloud to realize the potential of your plant and your people. And so what I'm going to talk about is, well, what's the problem we're trying to solve, and how does the cloud help with that? So we can pretty simply summarize, three of the main factors that cause process units to fail to achieve their full value. And the first thing is upsets. So there's some kind of plan, there's an upset, and we either lose availability or we lose performance, and so we're suboptimal. The second thing is a kind of, not necessarily an upset, but due to kind of degradation or changes in the performance of the plant, we start to drift away from our optimum. And then the third one, which is a little bit subtle, is actually maybe the plan or the target wasn't as good as it could have been. So there was some potential there to do better, and no one ever tried, and so nobody ever knew that there was a gap. And so essentially, to solve those problems, what we're looking to do is either respond more quickly to things that go wrong, so that we resolve issues faster, we get back onto our plan quicker. The second thing we want to be able to do is identify things that are going wrong before they become a constraint. So if you like, look below the surface and really understand what's going on at a deep level, so that we can take action and mitigate problems before they're losing us money. And then the third thing that we need to do is find opportunities and improvements to actually run in a better and a different way that's better than we'd previously thought we could do. Now, Copilot is KBC's solution or service to solve this problem, and the name Copilot comes from an analogy with an aircraft. So in an aircraft, the pilot has his hands on the controls, is flying the plane, and the co-pilot is there at his side, checking the systems, checking the weather, communicating with the ground, and then if there's something happens, then the co-pilot can step in and support and help the co-pilot to achieve what they need to do. And so the analogy is that our customers are still running the plant, they're the pilot, and then the KBC co-pilot is by their side, ready to help. Now, what does kind of Copilot comprise of? So these are some of the ingredients that we think you need to use the cloud to improve the performance of your plant. And it's kind of three things. So first thing is, well, why use the cloud? And really what the cloud gives you that other ways of working don't is this potential for collaboration. So because data is in the cloud, it can be made available all around the world. It can be made available to people in different time zones who can work while you're sleeping. And it can be made available to a much wider range of experts. And so really the point of the cloud is about collaboration. And so it's linking up your site on the left, so that's your people, your physical assets, and your economics, linking them to connected experts around the world. And that could be the KBC Copilot, could also be third parties. Now, there are different ways of structuring a cloud-based service. So you could put all of the technology. So the second piece is the digital twin, which is a shared single version of the truth that tells you a little bit more than just the raw data. So there's analytics, there's the models that are a bit more insightful than just the raw data. You can just share raw data, but we believe that putting a digital twin in the cloud is valuable. And I'll talk about later the difference between a simulation and a digital twin and what that gives you. So you can locate all of this stuff on a third-party site. So there's cloud-based outsourcing, which is something maybe you're already using it. And what that does is all the data moves out to a third party. They can run their models and do their analysis, and then recommendations and insights come back. Now, the KBC's philosophy and what we believe is actually more powerful than that is not to put all that stuff hidden away at a third party. It's in the cloud and it can be shared by everybody. So the software, the tools, the models are available for KBC's experts to review, but they're also available to your people. So everybody has access to this stuff. And the other thing that travels backwards and forwards is questions and advice and capabilities. So we're not suggesting here replacing your people with remote people. What we're saying is use the power of the cloud to transfer the knowledge and capabilities from third-party experts into your people. And so you're not sort of hollowing out your own skills, you're building up your own skills. So there's the cloud for collaboration. There's the three things that we think need to be brought together: a cloud for collaboration, the digital twin to provide the deeper insights, and then human expertise to hang it all together and make it work. So going back to the poll results, it's not just about a piece of IT, it's about making it work for real people, real business processes, and real working problems. Now, just to quickly touch on, this phrase "a digital twin" is now being very commonly used, and basically a lot of people who've previously talked about simulation models have started calling it a digital twin. And so I wanted to just put some suggestions for what we believe is the difference between a process simulation and a digital twin. And a process simulation is kind of a one-off, and a digital twin is an automatic, accurate model that covers the full range of operation, the full past and future of the plant, and is a single version of the truth that everybody uses. And so that makes it different to just a process simulation that one engineer has on their PC. And a digital twin is really valuable, but you need a higher level of robustness in the simulation, and you need a higher level of robustness in terms of looking after it to make sure it's always accurate if you're going to actually be effective with it. And the fundamental value of a digital twin is speeding things up. So speeding up spotting issues, speeding up resolving them. So just one example. Traditionally, someone might spot a problem. Perhaps it's a problem on the plant, perhaps it's a problem with the LP model. And then to resolve that, somebody has to run a model, they have to get some data, they have to set up and tune the model. Then everyone has to agree that that's a good base case. And only then do you start actually finding a solution and looking at opportunities. Now, compare that with a digital twin. Well, when something happens, the digital twin has already run itself. You've already got an accurate model, an accurate version of the truth to work from. And you can straight away start solving the problems. Now, the other piece of speeding up that process is, well, solving that problem becomes much quicker if you have ready access to a worldwide network of experts who've seen it before and know solutions. So this is all about basically addressing problems more quickly, hopefully even proactively before they become a real problem, and so avoiding losing value while things drift away from where they should be. So just a quick case study on the value of this type of system. So there was a Coca heater in the United States, and they had problems. They had loads of outages and they had short run length due to the fouling. And the other problem was that the run length was pretty unpredictable. So they didn't really know, well, could it be extended? And it was always a bit of chaos to organize the maintenance. Now, the first thing that we did was, well, using a simulation model or digital twin, we were able to predict the run length much more accurately. And so then we had a handle on what was going on. And because we knew what was going on, we could then control the operating envelope in order to get the run length that we needed. So the model was then used to generate KPIs, generate an operating envelope, and then by controlling in that envelope, within 2 months, the operation was stabilized, and the benefits from controlling and increasing the run length worth around $8 million a year. So there's a combination there of the modeling, the prediction, and of course the human side to understand this and then turn this into some actions that would actually improve operation. So what are some of the applications? So I've talked quite generally, okay, we have a digital twin in the cloud, we're sharing this data. Well, what are some of the applications that we can use this for? So starting on the left-hand side, the first thing that we can do is just share data. So you can use the cloud to move data around to people that need it. So we have some tools called Web Technician, which is our secure way of reaching into a site and moving data out. We're hosting data in the cloud, the digital twins, the dashboard and portal, just for sharing the information. The next level of cloud-based collaboration is something that we call model performance assurance. So there are often situations, we talked about the value of a digital twin, but also the challenges of keeping it up to date. And as our tools become more and more complicated, it becomes more and more difficult to actually maintain them. So we see quite commonly with digital and IT projects, process simulation projects, some tool gets built, people get trained to use it, all well and good, and then people move on, change roles, the plant changes, and the tool is no longer accurate. Then what happens is, because the tool is not accurate, it's not generating particularly useful results, and so people lose trust in it, they stop maintaining it, and then it falls into disuse. So what was a valuable and powerful tool becomes useless over time. So the first thing you can do is just what we call model performance assurance. So the remote co-pilot can supervise the model, make sure that the data is okay, make sure the model is calibrated and the results are sensible, and take proactive action to correct the model and improve it, so that basically people on site can always trust that tool. So the whole problem of managing the digital twin is just taken away, and then the site team have got it, and the interpretation and assessment of the model results is done by the site team. Then some of the other applications then build a higher level of subject matter expertise on top of that. So plan assurance is looking primarily at, in a refinery application, that would be looking at the performance of the LP model, making sure that the LP is correct, making sure that the unit is running to plan. Another application is unit health assurance. So this is looking at the trends over time. So using the fact that a digital twin can see things or calculate things that you can't measure directly. So for instance, fouling factors, distillation tray efficiencies, efficiency of a compressor, those things you can't measure directly, but you can calculate through a digital twin. And then by trending them over time, you can identify issues and then step in either for maintenance or inspection, or just an engineering investigation. And then the final application is what we call operational performance assurance. So this is looking at kind of day-to-day, how well are we operating and addressing troubleshooting issues, short-term actionable recommendations for operations, and any or all of those in different combinations are possible. So KBC, currently we have 2 Copilot services available. We've got what we call unit performance assurance. So this is built on a Petrosim digital twin and is focused on assuring the performance of a process unit. And then the second we have is Energy Management Copilot. This is based on a utility digital twin built using Visual Mesa and is focused on energy optimization. And we have a pipeline of other services sort of in the works. Now, at this point, I was going to do another poll and gauge. So I'll hand over back to Claire. Just to gauge sort of where people think that the issues are, or some of the challenges that are being faced. So I'll hand back to you, Claire.
Sure, thank you, Tim. Okay, so our next poll question are, what are typically the biggest barriers to improving the performance of plants? So we have a few options here for you to select. So lack of understanding where we are today, lack of time to do anything more than firefighting, unable to diagnose or agree what the problems are, unable to identify solutions, and unable to implement the solutions identified. So pick one of those answers. So what are typically the biggest barriers to improving the performance of plants? I'll just give you a few more seconds because I can see you're all voting. Okay, so let's look at the results. Okay, so it's pretty even between lack of time to do anything more than firefighting and unable to diagnose or agree what the problems are. Great. Okay, so I'll hand back to Tim.
Okay, thanks, Claire. Yeah, so it's interesting, and again, we see these. The results have disappeared. Can you keep them on the screen, Claire? I'll just quickly talk to those results. Or is it too late? Nope. Okay, great. So let's just quickly talk about those. And we often see that actually the firefighting issue is really significant. A lot of operations are very lean, and it's quite frustrating. You know, a lot of engineers know what they should be doing and could be doing, but they just don't have the time to do it. So that's you know, a very common problem. And then it's quite interesting, isn't it, that the diagnosis and agreement of what the problem is the real issue here. So often, if you know what the problem is, it's pretty clear what the solution would be, and then if everyone knows agrees what the solution is, it's relatively straightforward to implement it. But this diagnosis, you know, understanding what the problems are, is a key issue. And this is one of the, well, both of these things are things that we would address through Copilot. So the first thing is by providing kind of supplemental resources, we can kind of break this cycle of just firefighting, become less reactive and more proactive, because we're seeing issues before they become a problem. And then the second thing is this diagnosis and agreement what problems are. Well, there's an issue, if typically engineers today are only on a certain unit for, I forget the average, but it's sort of 3 to 5 years. And so you haven't seen this whole history of the problems on the unit. You've maybe only worked on a couple of plants, and so it's quite difficult to, even if this thing's happened before somewhere else, that knowledge and experience is lost. And this is an area where having people who, experts who've seen dozens, maybe even hundreds of that type of process unit can much more quickly diagnose and find that problem. So can I share my screen again, Claire? And I think that leads quite nicely onto the focus of a Copilot assurance system will change over time. So what we often see is that when we just get started, there's a lot of one-time improvements, right? There's we see an issue there and we can make it better. The mass balance on the unit wasn't great, and then we can improve it through using the digital twin to verify the data and create a physics-based mass balance, and that gives everyone a whole load of insight, and they can immediately take some actions. If the mass balance has never been that well solved, then the LP is probably not very good, so you can get a big quick win by improving it. So there's an initial phase of just addressing some problems, but then over time this migrates from resolving issues to more looking ahead, observing patterns and trends, deeper analysis of the variables that weren't measured, to be able to more proactively deal with things. And then eventually we can sort of settle into this mode of really fine-tuning the optimization, revising the target levels and alerts, adding more detail. And so I guess my message really from this is the problems you have today are probably different to the problems that you have in future, and the value of this type of cloud service will change over time to address whatever the key issue is at hand. So just a quick slide about why KBC makes a difference here, and why our service is perhaps different to others. We've got, and you're probably aware of this, our leading technology and expertise. So simulation technology, energy management technology, and really experienced consultants who've been around the block and know how to deal with the issues. We have a real focus on collaboration and capability transfer. So as I said before, KBC's focus is not to provide an outsourcing service. Our focus is to provide a service that builds up your capability, that sort of supercharges your expertise with ours, and that transfers our knowledge to you. And then the third piece, mentioned in the poll at the start, that change management is a really key issue to the adoption and use of digital tools, of any digital tools. And KBC are really strong on integrating this digital technology with operational excellence. We've really built our change management elements of Copilot in order to really dig into who is going to use these outputs from the digital twin. How are they going to use them? What's the interaction going to be like on a daily, weekly, monthly basis? And that's really key to making this a success. So at this stage, so that's about half an hour. I'm going to give a very short demo, and then we'll have open for questions. So if you want to start thinking of questions, enter them into the chat, and Claire will organise that. So I need to stop presenting. And I'll keep the presentation just in case I need it later. Okay, so a few elements of what Copilot has. So I mentioned before, we have a digital twin. So there's a model, there's a dashboard, and there's a collaboration portal. So what we've got here is the overview entry portal. So all of the tools and systems are all accessible through one place. So there's a dashboard, there's a collaboration element, there's the actual models themselves. So I've already got this up and running. So for instance, this is an energy model, and the model is fully accessible through Copilot. It also links, there's a sort of seamless link to and from the energy model and the energy dashboard. Second example, so this is an FCC Copilot dashboard, and I guess one of the things I wanted to illustrate was when we talk about, well, how do we lose value, and there's a couple of ways. So there's the unit doesn't perform, and there's also maybe the plan itself was not optimized enough. So very, very quick example. If we look at the FCC product yields, we can see a couple of things here. So in our digital twin, we're actually running, we've got the plant data, which is the black line. We've got the digital twin, which is the green line. And actually within our digital twin, twice a day, we're running the LP submodel. So the LP was used to generate the plan and targets. And so we're running that in real time as well and comparing it with the simulator and with the actual plant. And you can see some interesting things here. So this is the LCO yield, and the digital twin and the plant are matching very well. So that's the green and the black line are pretty closely matched, but the LP doesn't seem to match so well. So this might be an indication, very simplistically, that the LP could be a problem here because the simulation and the plant seem to tie up. If I compare this with the gasoline yield, and there's an alert on this, you can see here the simulation and the LP seems to be lining up, but the actual plant isn't. And so this indication here that there might be a plant problem. Now there's a whole dashboard we can drill into, but what I really wanted to show you was Copilot is not just a piece of technology, right? So you've probably all got dashboards already. You've already got models, and Copilot is not a dashboard. Copilot is a collaborative service. So just a quick illustration of how that works in practice. There's also this collaboration portal, and there's communications, actions, library of documents. And so example here, this has been flagged up. The FCC gasoline yield is lower than forecasted. And so Magnolia is the customer engineer, and this is me pretending to be an FCC expert, which I'm not, I have to say. So there's a little bit of fiction here, but we've raised this problem. The Copilot has got some courses of action and some suggestions. It raises an action. The client's had a look at the possible action. It seems we're losing gasoline into LCO, and then the Copilot's back, well, I'm now going to look, I'm going to rerun the simulation, look at the fractionator performance to see if I can understand why. And these actions are, created, put on an action list, and are available. You can see tracking through, are they implemented or closed? So it's just, as I say, it's just an illustration really of the service, that there is some technology and there are dashboards, but there is also this human interaction, which really sort of speeds up getting the results out of it. So I will call it a day there. If I go back to this presentation. So at that point, I will open the floor to questions. And I think Claire is going to run this. So
Yeah,
Claire,
thank you. Thanks, Tim. Yeah, we have had a few questions come through. So the first one is, in the sphere of oil and gas company digitalization, where are you seeing the fastest changes occurring?
Okay, thanks. So I think there's a real amazingly fast change on perceptions around cybersecurity and cloud access. So even just a couple of years ago, there was a lot of resistance to this kind of thing. Everybody was worried. IT departments were quite defensive because they sort of felt like their control over things was going to be eroded, and in fact might kind of put them out of work. And even just in the last 12 months or so, or maybe 2 years, that's just totally flipped on its head. And so previously, we would see IT departments were a real blocker to this kind of service. They were always the last ones you had to convince. Whereas now it's the other way around. IT departments are coming to us because they would actually, they have a challenge, right? They have to manage data, move it around, and actually this can make their life easier. And so some of this is now driven by IT wanting us to take stuff into the cloud and take it off their hands rather than them being the blockers to it. So that's I think the fastest change that's happening.
Great. And a couple of people are asking, how long does it take to get a Copilot system up and running?
Okay, and that's a great and quite an interesting question. So I would say between 8 and 16 weeks, which is quite a wide range. And the reason the range is so wide is, well, one thing that we would do very, very early on is something called a digital readiness assessment. And you actually need, there's probably 5 things you need to have in place in order to make this a success. So the first one is policies and legal stuff. So, that can be a blocker. People want to do it, but actually the policy doesn't let them. The second thing is data. Partly what data you have, and secondly, how's the data being managed? Because we need to build systems to make the data flow around in really as automated a way as we can. We don't want human beings having to manually. We can do it. You can manually enter data into Copilot. We don't really want that. So how we're going to move data around is a key thing. The third thing is models. So if we're going to have a digital twin, usually there's some kind of simulation that we can start from. But how robust is it? Is it really going to work across the full range of operation? Does it have the detail level that we need? So that's something that that could range from we have to build one completely from scratch, or we just get one and we mirror it in the cloud and plug it in. So big range there. The next one is around the human side of things. So what are the work processes? So who's going to use the service? What are they going to use it for? What are the work processes? Where will Copilot outputs feed into existing work processes? Do those work processes need to be changed? How we're going to do the change management of that? And so again, that can vary hugely from some people are kind of ready to go, and as soon as the information comes, they can just start using it. Some people don't have any documented work processes. Their work processes are totally ad hoc, and so we have to kind of build that. And then the final one is IT. So just what systems are there? There are, when you get into the nitty gritty, there's different ways to do the IT connections, and so does customer IT stuff need to be updated? So there's quite a wide range of maturity on those 5 things. So it, as I say, could be about 8 weeks, or could be twice as long as that if we have to address all that stuff.
Okay, and our next question is, how is information collected from the plant? And there's a question mark next to OPC.
So I mean, this would probably be better to talk to one of our cloud IT experts, and there are different ways of doing this. So generally, there'll be some kind of VPN into the data historian. There's then, so it's not just OPC, because it's not just the historian data that we collect, right? So that'd be part of it, but there's we also might be collecting economic data. So yes, but there's more to it than that, I suppose, is the answer to that.
Okay, good. And another question, do you see projects for new plants and be part of the design of the plant?
Yes, we do. So it's perhaps a slightly different situation, but absolutely yes. So we do process studies, energy studies for new plants, and yeah, support those. The cloud-based thing is a little bit different in that instance, because there isn't the kind of streaming real-time data from the actual plant at that stage, but there might be still, you know, cloud-based collaboration, but it's a bit simpler in that case. But yes, we do.
Okay, I think we've got time for just one more question. Does the model handle actions run along with operators that influence the working of the models, such as set point changes?
Yes, basically. I will quickly show you an example. No, it's always dangerous to go off script in a demo, but I will do. If I go, the best example is here. So this is the energy optimizer actionable items, and so there are some suggested changes to the steam flows from the boilers, the routing of steam through compressors. Now, through turbines. So so the actions here could be a change in set point, and they could also be a discrete a switch. So, you know, if I've got 5 boilers, do I need to run 3? Do I need to run 4? Do I need to run 5? And so there could be an action to switch something off, for instance. So in this instance, those actions are just provided to operations, and then they make the decision whether to make the change. We do also run this in closed loop, so not for the switching, because nobody I've ever met wants an automatic tool to start switching turbines and boilers on and off. But for the variables where you can vary the flow rate, that can be done in closed loop. So short answer is yes.
Brilliant, thanks Tim. We do have quite a few more questions, so thank you everyone for sending them through. We have run out of time today though, so what we'll do is we'll get back to you individually. If you do have any more questions after the webinar, feel free to get in touch with us, and we'll be able to answer them. So all that's left to say is thank you for joining, and thank you to Tim for delivering today's webinar, and we hope to see you on one of our webinars soon.
Thanks very much everyone.